Muy bien. Voy a... ¿me podéis confirmar que veis la pantalla?
Se ve perfecto.
Vale, perfecto. Muchas gracias, Anya. Well, yeah, I'm going to switch to English just because I make the slide in English. So, you know, I'm just going to switch. But first of all, you know, if anybody has any question along the way and, you know, I'm not following or like anything, please feel free to, you know, stop me. You can use anything in Zoom, like, you know, any like hands up or anything, you know, if you have any question and so on. So please, you know, don't hesitate to do so. And also, before I jumped into the presentation, I want to say that you know, the reason that I'm talking, like, you know, I'm giving this workshop today is exactly that. So I attend I mean, it's exactly the reasons that Anya was mentioning before. So I attend, you know, this workshop that Natalia was actually sort of like, you know, presenting that day, and you know, I just engaged with Natalia. I share a couple of messages with her, and you know, we sort of like agree that I could give this talk. It took me a while because it's been like a very busy year, but you know, please don't hesitate if you have, you know, any talk that you are burning inside with, you know, you want to share it with everyone. Contact, you know, just send a message on Slack, and I think it will be great for everyone. So okay, so let's jump into the Tidymodels presentation. So you know, I think maybe it will be good to, before I jump again into the slides, it will be good to know whether, you know, you guys or anybody in the audience is using Tidymodels currently. So, you know, if anyone is using it, it would be great to, you know, just say, yes, I am, or something like that. If I don't hear, we don't hear anything, I presume that no one is using it. Okay, I hear a no, actually. I mean, I read a no in one of the pictures. So, okay, so I presume that not many of us are using Tidymodels. So, you know, well, I'm gonna start with the slides. I mean, Annie already has introduced Our Ladies, but just to say again, like, you know, Our Ladies is an open community, and this is a presentation that is following a code of conduct, has a code of conduct to follow. So, you know, we abide to those rules. So Annie again already has introduced me. That if you want to, you know, get in touch and so on, yes, those are my handles, so you can find me there. And before I jumped into the slides as well, I need to thank a lot of people for you know, the slides that you are gonna see. Because many of them actually they come from Josiah Parry. So he is a customer success person in our studio. So these slides were adapted from his slides. So much of the content that you're gonna see today, they are from his slides. I will also recommend that there's a lot of links that I'm gonna share with you in the presentation, and you know, we can write all those down, but I will also recommend to see the content from Alison Hill. So she is a former employee of our studio, but I will totally recommend, you know, just Google Alison Hill Tidymodels, and you're gonna find a ton of resources on Tidymodels. So I will go through it today, but if you want to go more in depth, please visit her contact. Also, you know, for the way that I arranged the slides, and you know, how these slides were built. So they were built in Sarengram. So I learned a lot actually from Sylvia Canelon, and obviously UC is the one that developed the slides. And really the Tidymodels team in our studio, because I think they made a fantastic progress during last year on really putting together great documentation on Tidymodels that you're going to see on the website you know, how well structured this is. So what we're gonna see today is really sort of like a taste of the Tidymodel verse. So I think basically what RStudio has made really in the last year is sort of like put the models that you know, we could use in R in sort of like tidyverse structure. So everything is way more organized. And if any of you have used the Caret package, you know, for modeling, or any other sort of like packets for modeling, I think that the Tidymodels provides a really good structure to do modeling really. So as I said, we're gonna see some useful link. So I think the first one really, should be, sorry for this, should be the Tidymodels website itself. So I'm gonna, Anya, can you confirm that you see the Tidymodels website at the moment?
I do.
You do? Okay, brilliant, thank you. So yeah, you know, I will encourage you all to go to the tidymodels.org website, you know, whenever you want to learn a bit more about Tidymodels, because it's really well documented. So, you know, you have a section for all the packets that they are inside the Tidymodel. So this is what we're gonna see sort of like more in details today. But if you want to read more about it, please go to this website. So this, you know, they have a section about the packets. They have another section about the, you know, what models you may want to use, and so on. So everything is really well explained here. They also have, so there's currently a book as well that Julia Silge has, you know, she is one of the authors of the book. You know, everything is really well explained here. So as you can see, there's also another section for help, where, you know, maybe you are stuck with one model that you are building. So obviously you can, you know, ask questions in the RStudio community website. You know, they encourage you to use the repex for packets to sort of like help them to help you when you have any questions. But there's a bunch of resources to find help. And also, like, you know, if you are using Tidymodels more often, you can of course contribute. So, you know, they have a code of conduct as well, and they explain you how to contribute. But yeah, I think this is a really fantastic resource, so please do visit it. So this is one thing. And there's also a Slack for you know, if you want to sort of like force yourself to learn more Tidymodels more in deep after this presentation. There is also like a book club that is going on. So if you are interested in joining, and I know I follow sort of like the second batch of it, but I know that they keep having you know, new batches every month basically. So there are different days where you know, you might be able to join in case that, you know, you have scheduled classes and so on. So if you are interested in sort of like learn more about Tidymodels from a book club point of view, you can visit this link here. So okay, so basically you know, I think those are the sort of like the useful links. And so, yeah, let's sort of like jump into Tidymodels. So first of all, as you know, you have probably, I guess, guess from like the, you know, when we visit the website, you probably have seen that Tidymodels is sort of like infrastructure, I would say, that includes different packages, and then each package has a different objective. So, you know, it does different things. So this is again, like, you know, very similar to the tidyverse approach, where, you know, you may have a deployer, you might have reader R to read the table, deployer to format it, some packages to do some modeling and so on. So these are the main packages that they are included in Tidymodels, but these might not be really up to date because there's more, there are more packages being included as we speak almost. So for example, there's this new package called stacks. So this is, for example, when you are doing multiple models and then you want to compare across them. So that package was is one of the latest additions, but they will have it in the website. So if you visit it, you will be able to see what's being added as well. But what we are gonna go through today is mainly the package here on the top. So this is really what you will, I would say, certainly always will have to use really. And then there's some, I think the package on the bottom. At least from my experience, right? I mean, like, maybe I wouldn't use Broom necessarily, but it's probably more likely that I will use Tune to sort of like, fine tune the model at the end, but maybe not necessarily. But I will say that the package on the top row, is probably fairly certain that you will use it if you are using Tidymodels to do modeling. So so let's go in deep into this into these packages first. So yeah, so as I said, basically, if you are using the Tidymodels approach, this is mainly what you will do, right? So you will have to import your data, do some wrangling to put your data in a tidy way, do some transformation, visualization that you may do with ggplot, and then you do some modeling, and then go through that iterative circle to understand your data more and more, and then eventually, when you understand your data, you may communicate it. So so this is sort of like the paradigm of the tidyverse. And these are the packages really that allow you to do that. So as you see, the Tidymodels, the Tidymodels package will sort of like fit here, where when you are doing your modeling. So obviously, it's very unlikely that you will use Tidymodels in isolation. It's likely that you will actually plot your models with ggplot2 and so on. But this is really where it will stand. And so, if you are to use some modeling, obviously, it doesn't really matter that you are doing it in Python or you are doing it in R. The sort of like the rationale behind the modeling is very similar. The steps that you have to do. So you may have to, take your data, and then you may need to do some data preparation. So this might, this might involve splitting the data into training and testing and so on. And that doesn't matter. Like if you're using scikit-learn in Python, you will have to do it. If you are using R, you will have to split your data, for example. And so we're going to see how to do that. So just, the modeling workflow is not going to change from platform to platform. It's going to be the same. So just just don't just stick into the modeling workflow really. So so as I was saying, the first step really, once that you have the data, will be the partitioning, right? So you will have to, if you have a big sort of like data set, it's very likely that you'll have to split it at least into training and testing and validation, probably. So the first package of the Tidymodels is rsample. So this is sort of like, if you are with a sort of like tidyverse mentality, this will be the first one. So this is sort of similar to read CBR. So this is really the first thing that you'll have to do. So okay, so how do we use rsample to split the data? So basically, the first thing that we want to follow the training and testing splitting steps. And so in our sample, there are 3 key functions. So the first one is initial split. So basically, yes, that's the function that you feed it the data, and then you tell what is the proportion that you want to split it into. And then you can also, there's another argument called strata, and that's in case that you want to use one of your variables for that splitting. And then the second one is training and testing. So there's a lot of words. So let's see how this really works in practice. So for example, imagine that, we have the iris data set. We could have used really other data sets, such as, the Palmer penguins or other more recent additions, I would say, to the our infrastructure. But just for the sake of it, I think because everybody is very familiar with the iris data set, let's just use the iris. So for those of you who might not be familiar, this is just some annotation on iris flowers. So this is just a species of flowers, and then they have I think it's 4 variables. So the length of the petals, and then the sepals. So different parts of the flowers, and how so basically the measurements, like the centimeters of the flowers. So there are 4 measurements, and there are 3 species of flowers. So the total number of rows in this data set is 150. And then, there are 5 variables, basically, because 1 is a species and then 4 measurements. So I think it's like literally length of like in the 4 dimension. So yeah, that's your iris data set. So basically, this is the first function of our sample. So is initial split. So we're going to split the iris data set. We want to split it into 2/3 for the 2/3 that is going to go into the into the training. So we're going to give the training more data, and then 1/3 into the testing. And then we're going to split the data based on the species. So as I said, there are 3 species, and this data is going to be split into that. So the output of after calling this function is this object. So basically what it's telling you is like, okay, you start with 150 variables. So the total is 150. And then for analysis, you're going to get 100. And then for assess, so this will be for your training, there's going to be 50 rows, basically. So this is the initial output. And then the other two functions that we can use is, once that we have the split, we need to call training and testing. So we call training and testing on the split. So training initial split, and then as we can see, it's just basically a subsection of the iris data set. And then, as we saw before, we're going to get 100 rows for the training. And then if we do the same for the testing, calling the testing function, we see that it's literally a subset of the iris data set, and then we get 50 rows. So 50 rows go into the testing data frame. So, okay, so we have our data split. So then once that we have the data split, the next thing that we need to do is do the modeling. So really the hardcore of the modeling is in the parsnip package. So this is just a sort of like a side story of why this is called parsnip. Is really because a lot of the modeling before the Tidymodels existed was done with the caret package. So the caret package has a lot of different models and so on, but they wanted to come up with a different vegetable, someone that was similar to a carrot, but not exactly the same. So a parsnip is somewhat similar to a carrot. So that's why it's called parsnip. So the hardcore really of the models is going to be taken care of by parsnip. But in the Tidymodels infrastructure, there's package beforehand called recipe. So this one here, that is sort of allow you to do the transformation. So, you know, once that you have the data split, there might be quite a lot of things that you may want to do with your data before actually putting into the model. So, you know, you may want to log transform it, you may want to remove your NAs, and there's a bunch of things that you might want to do. And this is done in a tidy way with the recipe package. So let's have a look. So yeah, as I said, it's basically a preprocessing interface. So, you know, if you need to do log transformation, there's a really long list of things that you could, you know, basically mathematical transformation that you could do. You could do it inside the recipe package. Yeah, there's a dplyr-like syntax, and what this means is that there's a lot of things that get piped. I really like this sort of a structure. So for example, like, you know, if you have used scikit-learn, you may do your steps sequentially, whereas, you know, in the recipe, I think the recipes package is very nice because it allows you to put everything into a pipeline, all put together with the pipe. So I think it's really nice because it's really easy to read after, you know, what processing steps you are doing to the data. So there's that. And yeah, there's like, this is more, it's more technical. So yes, it's basically, there's a tidy select like syntax. And what this means really is that basically a lot of the things are done in steps. So basically what we do is we create a recipe. So to create a recipe, you know, we start with our data that we have already split. So this will be our trained data set that we generated before. And then what we do is we create a recipe. So basically what we want to do here is to use the training data set to predict what species, you know, to predict the species of our data. So basically we put everything into a recipe, and as you can see, and this is how we do it, we wrap it into this recipe function. And so by doing that, we create a recipe. And so if we see what is inside, we see that, you know, we have one outcome. So this is the species, and then we have 4 predictors. So this is, as I was saying before, the different, you know, length of the flowers in the iris dataset. So, you know, we start creating that recipe, and then we do apply steps into the recipe. So for example, you know, the steps can be center if we want to center the distribution of our data set. We can scale it, we can log transform it. There's a bunch of steps. So let's have a look actually. Again, you know, I will encourage you to go into the Tidymodels website, and then you know, in the reference section, you can see here what step you can do. So for me, for example, I find really useful to use log transform, but you know, as Anya was saying, I'm a bioinformatician, so basically I do a lot of, like, you know, log transformation and so on. So you can see all the steps that are available here, but they are really advanced. So log, you know, step log is here, but you find all of them here. And as you can see, they all start with a step. So that's, I think that's really useful. Okay. So okay, so there's that. You can see the slides again, right?
Yeah.
Yeah, brilliant. Okay, cool. So yeah, so there is basically that. Yeah. Yes. So and then again, like, this is more into detail, but as you see, like, everything that is written into the recipe recipes package has this, it will start with a word, so it will be either like all predictors or hash types. So for example, some of the things that I do as well is like, imagine that in our case, all the data are numeric, the length of the flowers is numeric, but in some cases you might not always work with numeric data sets, so you may want to apply a step where all your data, you want to include only variables that they are numeric, so you can use this step called or numeric to do so, for example. But I think it's really nice that it's fairly it's very standardized, so that's why it has a deployer like syntax. So for example, if we are back into the iris example, we start with our recipe that we prepared before, and then what we can do is like, we can center and scale our data set, and then so, to do that, we're gonna center all our variables that they are numeric. In this case, we know that they are numeric, but we can, specify it, and then we can scale it. And then again, like, we have our recipe that is slightly modified. So I think that's why this package is called recipes, because basically you are sort of like cooking, right? Like you are transforming your data, might be slightly different, but at the end of the day, you have a recipe. And this is what this is gonna be the input of the model itself. Okay. Once that we have the recipe, what we need to do, and after we are done specifying the preprocessing steps, so we don't want to do any more transformation with the data, what we do is we prep our recipe. So this is sort of like, sort of like to have the recipe ready. So a lot of the functions of the recipe package, and not surprisingly, have like a cooking sort of like meaning. So once that we have the recipe, we need to prepare it. There is another function called use it, which is sort of like to extract the data. And there's another function called bake it, to sort of like use that recipe, sort of like is the end product of that recipe, if we want to use that recipe for another model. I think that's more advanced, but so if you guys see recipe functions and you get to see all these cooking verbs, they probably belong to the recipe package. So yeah, once that we have the recipe, the first thing that we need to do is prep it. And so, I'm just here, I'm just prepping that recipe. And when I do that, what you see is basically that that recipe has been, is ready, is trained, as you can see here. So once that we have this ready, we can go into the actual modeling. So we have the data that is being is prepared for the model, and Parsnip is really the package that does the modeling step. So then again, like what we want to do here is to predict which species our flowers are, and basically, before the Tidymodels, before the Tidymodels, we could go to different packages to sort of like, use different models. And of course, you can do this even with Tidymodels. But so this slide is just here to appreciate that, different packages may have the same code. And with Parsnip, I think it's slightly easier to see what model is coming from what. And so basically there are 3 steps in Parsnip. So, well, yeah, this is the general interface for modeling. So it's really the hardcore of the modeling. So there are 3 specifications. So there's the model that you want to use. There's the engine, and then there's one more that I don't remember, but I guess it's the data itself. But yeah, so those 2 things, the model and the engine, you have to specify it. So so basically, as you can see here, we can create a model. Yeah, so I think that's why I was confused. So there are two things: the modeling, the engine, and the data. But you know, here we just showing the modeling and the engine. So so then, and the first thing is really the model. So for example, to classify those flowers, we can use decision tree model, for example. And then if we want to use that decision tree, in this case is classification, right? Because we want to see, okay, is this a species, what of the three species this particular data set belongs to. And so we use this model in a classification mode, and then we need to set the engine. So the engine is this R part, which is a type of decision tree. So this is the two things that we need to specify, really, the model and the engine. And then again, I appreciate that this is like, you know, there's too many things, but I will go back into the website and then, you know, see what is available, really, you know, what engines are available and what the models are available as well. The mode is always classification or regression, so that's easier, but there's a bunch of engines that you can select from. So this is just one example. This is another example where, you know, we may be using a decision tree as well in classification mode, but we can use a different engine. So the math behind the model are gonna be different. So, you know, we can create as many models as we want, really. Yeah, I just put a link here to the available engines that we have. So, you know, you can see them all, a lot of them here. So, you know, it will explain, like, you know, what mode you can select. So it's either regression or classification, the packets that is coming from, what model type is coming from, and so on. So there's a lot really to choose from. But basically, you know, the two steps that you have to give really to do in the parsnip step is the model and then the engine type that you're using. Okay, so then, you know, we have the data that we have it split, we have used recipes for the preprocessing, and then we are ready to, you know, we have decided what model we want to use. So obviously we have to connect all this, right? And obviously, being in the tidyverse sort of like mindset, we will expect to connect all this with pipes. And so the next package is called workflows. So basically what this package allows you is to sort of like put all this together in a workflow. And I think it makes it nicer as well. It's a more tidier way to put all this together. So you know, this is an example of how we will you know, link our ready data with our model. So if you remember, we have this model here, specify one, and then our already you know, ready training data set that we need to use. So basically, this is how we will do it without a workflow. So, you know, you can do this outside without the workflow package, but this is how we will do it if we use the workflow. So basically, the steps here is first you have to create a workflow. So call the workflow here, and then we add the recipe. So we add the recipe, and inside the recipe, we put our data that has been already prepped, and then we add the model. So, you know, first, what the recipe we're using, and then what model, and then inside, you know, you see here that is our specification here. So once that we have you know, everything bundled inside the workflow, what we do is we feed this data, right? So this is sort of like, this is classic step that you do when you do modeling, so you have to fit all together, and so the fit function is doing that for us basically. So we fit the workflow that we put together, and yeah, the data is the use use recipe. So we have our final workflow here. So so that's basically, you know, that's already the model is already done once that we are at this step. So, you know, everything has been trained by the model and so on. So obviously, you know, we want to see how well the model is working. You know, is the model good enough to tell us from using 100 observations from different flowers, is the model able to tell us which species they belong to? And so to measure that model, to measure the model really, so there are many parameters that we can measure of the model. So we can measure model accuracy, precision, and so on. There's the yardstick package. So yeah, it's a package for evaluating the models. So the predictions are returned in a table, which then again, like, you know, is a tidy structure, which I think is very nice. And yeah, it allows like easy, yeah, so because it's a table, it's very easy to compare across models. And so basically, you know, if we want to see how well our model has done, what we could use is basically we could take the result of our model. So if you remember, is this iris fit, and then we can compare it, and then we can compare it against our test data set. So if you remember from the very beginning, when I used the R sample package to split the data, we keep part of the data as the iris test. So this is you know, the testing data set, so it was smaller. So what we can do here is we can use the predict function from the yardstick, and then, you know, basically this is going to tell us how well the model predicted a class. So as you can see, there's going to be, you know, this table is going to have 50 rows because there are 50, you know, there were 50 rows in the iris test. So basically, this is how we use the predict function. So there are different, you know, there are different metrics in yardstick. So one of them is the metrics that basically it provides common performance estimates. So this might be, you know, as I said, maybe accuracy and precision, but if we want to be more fancy and, you know, we want to retrieve other performance of the models, we can actually create this ourselves. So we can use the function metrics set, and then this is going to allow us, you know, retrieve specific information from the model. So if we use the metric, you know, using the metric example, basically what we will do is we do, you know, we do call the predict function. So predict, like, you know, on our trained model, predict, you know, how well this model is predicting the testing data set. And then basically what we do is we put the result together with the testing data set. So these are going to be our predictions. And then basically we call, we call the metric function on these predictions, and then, you know, we have to say, you know, we have to say what we are trying to classify. So in this case is the species. So yeah, I think the model is not doing very well here, and we're gonna see actually later on why is the case. But the next thing again is that we can also specify what the other metrics from the model. So we can use the metric set, and then we can write here what exactly we want to retrieve from the model, and then we use the same structure. So give me all these metrics from the model. So so basically, this is really how the steps that we will need to use within the Tidymodels infrastructure. So the first thing is, to use the R sample packets to split the data into training and testing. The recipes package for preprocessing, so data transformation. So this could be log transform or other type of transformation. We use a parsnip for model specification. So what model and what engine what we want to use, and then we can put all together in the workflow packets. And then once that we have the workflow, and then we train the model, we have a model that has been trained, and then once that we have that, we can use the yardstick packets to measure model performance. So for example, if you use the carrot packets in the past, then there's a lot of the metrics that they were included in carrot, they are now included into yardstick. So for example, confusion matrix and so on. And these other packets that I haven't really touched upon for time constraints. So I can basically sort of like say what they do. So the Broom, is a really nice way to put statistics in a tidy way. So for example, if you use, for example, t-test in R, you're surely familiar with the fact that R is splitting like this result in a very untidy way. So Broom really takes care of that and then puts it into like a tidy verse sort of like a structure. So every column, everything will be in a tidy way. So every variable will be in a column, and then every observation is going to be in a row, and so on. So if you use, for example, if you are ever stuck into, oh my god, how I'm going to tidy my stats, and have a look at Broom, because I think it's very useful. Then the tune and the dials packets they are a bit more advanced in the Tidymodels, and this is basically to tune your model parameters. So here we really haven't touched we haven't done any hyperparameter tuning and so on, but it might be the case when you are doing quite a lot of models that you want to compare across all of them, and then you want to maybe tune your model parameters a bit. So train a bunch of models and then select the best model performance and so on. So those two packets are very, very useful for that, but you might not need to use them, at least in the first instance. So I would recommend to have a look at the other packets before, and then tune in into the tune and dial packets. So yeah, I think one of the things that I really haven't thought upon is like, really how, so this is really the infrastructure of what Tidymodels offers to do modeling. But obviously, I think today we haven't really done the best modeling that we could have done. I mean, like, we started with a really tiny data set. And so, for example, I would recommend in that case to maybe generate some bootstrap of the model. So this is when, your training data is very limited. So what you want to do is like, you want to sort of increase the space of your training data. So you can generate bootstrap, and then again in the R sample packets, there's a function to do that. We haven't really tested different engines, so this could you can test compare across. So for example, we have created two models, but we haven't really compare them across them, and this is something very useful. And we haven't really tuned the model parameters, so we just sort of like create the vanilla model and then use that from there. But then maybe with the tune and the dial packets, we could have improved a bit of model performance, I would say. And I think before I hand into Anya, I will also recommend, especially for those of you who are a bit more initiated, I would say, in the modeling area. You may not know Julie Silge, but she has like amazing Tidy Tuesday screencast where she does it live as well, but she has a blog post as well where she explains the models very well, and she goes really into detail into Tidymodels. So if you want to grasp more about Tidymodels, I will highly encourage you to follow her. And in particular, I think this screencast that she did last year, where she will go into the Palmer penguins. So this is this data set basically is pretty similar to the iris data set, but it's more interesting, I would say. It has more variables, there's NAs, it's very cute penguins, so it's a bit more complex. But basically in that screencast, what Julia did was to do something very similar to what we've done today. So basically, the model was trying to predict penguin species. So I think there are 3 species there as well. And basically using the penguin's height, weight, sex, and so on. But then she used I think she did bootstrap in there, so she increased the data that she was training on. So I think this will be a nice follow-up from this workshop. So yeah, I hope that this has been a good tasting of the Tidymodels. Obviously, if you want to get in touch, please do so. Also, as Anya said, join us in Slack, drop us a line there and so on. And thank you very much. And yeah, I hand into Anya.
Thank you very much, Maria. I don't know if anybody has any questions or would want to say anything. Y también las preguntas creo que también se pueden hacer en castellano, si alguien está más cómodo haciéndolas en castellano o en otro idioma. No sé, vamos a ver, no sé. En el chat de momento no ha salido ninguna pregunta. Nada, bueno, me ha sorprendido mucho el paquete, el recipes. Y creo que lo usaré bastante porque realmente el hecho de que estén todas ordenadas, ¿no? Con el step y la barra baja y tal, creo que hombre, puede ahorrarme muchos quebraderos de cabeza. Así que te agradezco muchísimo la presentación. Bueno, hay alguien en el chat que también dice buenísima presentación, ahora tengo más curiosidad en aprender Tidymodels. Así que genial.
Sí, a mí la verdad es que eso es una de las cosas que más me gusta porque es como que todo está muy, muy ordenado, entonces sí. O sea, por ejemplo, no sé, con Scikit-learn así está todo como más, me gusta más con Tidymodels porque está mucho más organizado y está muy bien. Y sobre todo los steps que puedes añadir uno o no, sabes, comentarlo simplemente y ver lo que pasa.
Bueno, está Gedia en el chat que dice, ¿sabes si se ha utilizado Tidymodels en bioinformática?
No sé si ella se refiere a un paper en concreto, pero o sea, sí, yo sé que hay gente que en bioinformática que lo utiliza, sobre todo para lo que estamos diciendo, o sea, para hacer transformaciones, sí. Yo creo que más gente, o sea, Tidymodels es bastante reciente en realidad y desde luego que Caret se utiliza un montón en bioinformática y yo creo que la gente, ¿sabes? La gente poco a poco se está intentando migrar a Tidymodels, sobre todo por todas estas ventajas que ofrece.
Genial. Vale, no sé si alguien más sabe ahora, es que no, vale, es que no veía si había manos levantadas, pero parece ser que no. Nada, Antonio Bermejo nos dice también, me ha parecido una presentación muy buena y un tema muy interesante. Curioso. También el paquete Broom también le echaré un ojo porque eso de que
Sí,
haga el reporting, ¿no? de las funciones más de base R en formato tidy también es interesante. Sobre todo, ¿no? En bioinformática quizás que a veces, pues yo qué sé, hacemos tests a saco, ¿no? Pues sobre muchos genes o sobre muchas variables en masa, ¿no? Pues
Sí, lo recomiendo. Y también junto con Map, o sea, por ejemplo, con el
sí,
paquete POR, sabes que, exacto, o sea, que tienes un montón de datos, entonces funciona súper bien, sabes, puedes poner
se
una lista,
integra.
exacto.
Perfecto.
Sí, sí,
That's
sí.
awesome. Genial. Vamos a ver si hay algo más.